Good afternoon, everyone. If you could find your way to your seats, we're going to start the award ceremony and plenary session in just a minute or two. Thanks so much. Good afternoon, everyone. If you could take your seats, we're going to get started in just 1 minute from now. Thank you. Okay, I think we're going to get started. Good afternoon, everyone. I'm Christopher Januzzi, Executive Director and CEO of the Electrochemical Society, and it's my great pleasure to welcome all of you whether you're on site here in wonderful Boston or joining us by a video stream from somewhere else in the world, to this, the 243rd ECS meeting and the 18th Solid Oxide Fuel Cell Conference. What a joy to see so many members of our esteemed community here with us today. And although much has changed in the world since the last time we met in Boston, which was in 2011, this meeting carries forward ECS's legacy of outstanding technical content. We have 46 symposia with over 2,900 abstracts, all coming from 59 countries around the world. With numbers like this, it's clear to see that if your interests lie in the electrochemical and solid-state sciences, you will find what you're looking for this week here in Boston. We kicked off the meeting yesterday evening with a lovely reception for ECS members, sponsored by our friends at Waters TA Instruments. Waters TA, thank you so much for that lovely event. But of course, we also would like to welcome those of you who have not yet had a chance to become ECS members. We hope that you take the time to learn more about this amazing organization and all that joining it has to offer. And that way, we can see you at our next members-only meeting, which will be taking place in the fall in Gothenburg, Sweden. But in the meantime, please do let us know if there's anything we can do to help you make the most of your experience while you're here at this meeting. ECS is incredibly fortunate to have a diverse array of meeting sponsors who support our meetings, including our gold-level sponsors, Giner Labs, Samsung SDI, and SES AI Corp., and our silver-level sponsors, ComSol Incorporated, Metrum USA, Pine Research Instrumentation, and of course, Waters TA Instruments. These organizations, along with the others listed on the screen, are critical to bringing this meeting to you. And we're very grateful for our many symposia sponsors. It is only through their support that we can offer the robust technical programming, and enriching special events that you'll find at the meeting. I'd like to give a warm welcome as well to our institutional members shown here. Through their support, they support our annual activities and their organization memberships. And it would be impossible to produce these meetings without ECS's divisions and sections, so I want to give them a special shout out. They are a vital source of financial support for our meetings and where they are the technical engine behind our content, and so I thank them for their support for this. And so on behalf of our divisions, our sections, and our many sponsors, I would like to wish you all the very best this week here in Boston, and I ask you to join me in welcoming ECS President Turgut Gür to the podium at this time. Mr. President.
Good afternoon, everyone. It's a great pleasure to be here with you in beautiful and historic Boston. I hope you enjoy the seafood. New England seafood is best in this area. I suggest that you try it if you haven't already. Well, I cannot express how excited I am to officially open and welcome all of you to the 243rd biannual meeting of ECS and the 18th International Symposium on Solid Oxide Fuel Cells. As my term as president expires at the end of this week, I would like to express my gratitude to you all for entrusting me with the great privilege of serving you and our esteemed society. I'm truly honored and humbled. Thank you. Thank you. I would also like to take this opportunity to express my gratitude to the Society's dedicated and tireless staff in the headquarters, as well as the leadership of ECS. They make everything happen. Behind the scenes, the tireless effort of the Society benefits greatly from the efforts of the staff to put these meetings together, to have the publications, the quality that we all aspire. So we are very grateful to have such a distinguished set of staff supporting ECS operations. As I emphasized in my opening remarks at our Atlanta meeting, as well as in my essay in the winter issue of Interface magazine, global challenges in energy, supply, and climate change top the list of threats to humanity. With this concern in mind, ECS recently affirmed the society's position by posting a statement on climate change on our website. So I suggest and advise that if you haven't read it already, please do so. Ongoing geopolitical unrest underscores the vulnerability of our energy security systems. It also impacts global emissions, worsening the prospect of irreversible climate change. This slide that I put up, on the upper left-hand corner, you will see that the world relies very heavily on fossil fuels still. In many countries, it is more than 60% of the electricity is produced by fossil fuels. And the projections on the upper right-hand side shows that although renewables, which is marked by green, increases rather fast compared to fossil fuel usage, the fossil fuel usage still increases in the amount, although their shares is going to be, of course, smaller by the gains of renewable energy. So if you look into the mid-century timeline, the graph on the lower left-hand side shows the CO2 emissions emanating from fossil fuel usage, both coal, natural gas, as well as oil. And of course, it is increasing monotonically, as you see, at least the predictions are, that we need to do something about it because the Earth is heating up, as shown by the red regions or the orange regions on the lower right-hand side. These gigaton and tera-scale challenges also provide opportunities to advance new technologies to help move us into a sustainable future. So there is reason for optimism because science has demonstrated time and again its ability to innovate solutions to address the societal needs and problems. I'm confident that we, as scientists, engineers, and technologists, can and will deliver again. I say that because as president and a proud member of the society for 50 years now, it's hard to imagine, the ECS community represents the finest minds in the electrochemical sciences and technologies. From fuel cells, batteries, supercapacitors for energy conversion and storage, to sensors, electronics, optoelectronics, to electrochemical industrial processes such as hydrogen production, electrosynthesis, and CO2 utilization and conversion to fuels, and to wastewater remediation, the work of all 13 ECS divisions is central to collectively addressing the most pressing global challenges. But time and speed are of essence now. We need to rapidly advance science and technology to innovate sustainable solutions for these difficult problems is more urgent than ever. We need an all-hands-on-deck effort. Our distinguished plenary speaker, Dr. Linda Horton, from the U.S. Department of Energy, will address these issues in her plenary talk just following our plenary ceremonies. I also believe that the complexity of global challenges can best be addressed and benefit from international collaborations. These are global problems, and we need international efforts that coherently address these problems and collectively address these problems. So I urge you all to actively seek out collaboration opportunities with our international colleagues in the areas of mutual interest, and this meeting is a perfect platform just to do that. It is in that spirit that our Executive Director, Chris Januzzi, and I recently visited several Asian countries to reconnect and re-engage with our sister organizations. We had the opportunity to address their general assemblies of both the Electrochemical Society of Japan and the Korean Electrochemical Society during their national meetings. We met with their leadership teams and discussed opportunities for increased cooperation and collaboration. I'm happy to announce and report that we now have signed letters of intent with KECS and ECSJ for joint activities to collectively address pressing global challenges, especially in clean energy area. I'm also happy to report that we put in motion the formal process of initiating nearly a dozen new student chapters in Canada, Japan, Korea, Mexico, Taiwan, Thailand, and Turkey, thus expanding our greatly valued student membership who truly represent the future of this society. But as much as this meeting is about looking forward, we are also here to recognize the accomplishments of our community, to honor our members for their contributions, and to celebrate. Therefore, I would now like to move to the ECS Awards and Recognition Ceremony program. First, I would like to congratulate our Division Award winners, whom you will find listed both online and in the meeting program. Please make a point to attend their sessions where you can experience firsthand why they are being recognized by their peers for the technical contributions and the quality of their work. Our first award is the Leadership Circle Award, which recognizes and thanks our institutional partners. The award is granted in a year a member institution reaches a significant anniversary milestone. Today, we recognize the following institutional members for their many years of institutional membership and dedication to ECS. With 25 years of institutional membership, we recognize the Jaeger Center for Electrochemical Sciences. Here to receive the award is Dan Scherson, Professor of Chemistry and Director of the Ernst B. Jaeger Center for Electrochemical Sciences at Case Western Reserve University. We're also pleased to recognize, with 70 years of institutional member with ECS, General Motors Holding LLC. To accept the award on behalf of General Motors Holdings LLC is Taylor Garrick, BDDV Technical Specialist, Battery Cell Electrochemistry of General Motors. Congratulations. Congratulations to all our Leadership Circle Award winners, and thank you for your continued support and engagement in the society. And now I would like to ask incoming President, Jerry Bode, to come to the stage and recognize our next recipients.
Thank you, Turgut. The 13 divisions of the Electrochemical Society ensure in-depth coverage of the Society's broad technical domain. Over the course of 2-year terms, division chairs not only oversee all affairs of their respective divisions, they provide stewardship at the Society level by serving on our board of directors. As part of the board, these chairs help to shape the future of our organization, and so we are truly in debt to them for their service. Please join me in recognizing the following past division chairs. All right. Graham Chick, OBE Division Past Chair, 2017-2019. Peter Masher, DS&T Past Division Chair, 2020-2022. Hiroshi Imahori, Nanocarbons Division Past Chair, 2020-2022. Shirley Mann, Battery Division Past Chair, 2020-2022. Jessica Caney, Sensor Division Past Chair, 2020-2022. Please join me in another round of applause to thank our past division chairs for their service to the Electrochemical Society. Okay, now I would like to take a moment to recognize a dear friend, colleague, and mentor to many of us in the Electrochemical Society community, who passed away earlier this week. Sri Narayan, past chair of the Energy Technology Division and co-organizer of the A01 Symposium, left us far too early and too soon. I will ask you to join me in a brief moment of silence to show our love and respect to one who will be dearly missed. On behalf of the entire Electrochemical Society community, we offer our sincerest condolences to Sri's family and loved one. Turgut, back to you.
Thank you. Thank you, Jody. We are now pleased to present the ECS Society Award winners, and I'm especially happy to mention that in addition to our 2023 winners, we're honored to be joined by an ECS Past Award winner who, due to the pandemic, was unable to be publicly recognized by his achievements. The Carl Wagner Memorial Award was established in 1980 to recognize mid-career achievements, excellence in research areas of interest to the society, and significant contributions in the teaching or guidance of students or colleagues in education, industry, or government. This award commemorates Carl Wagner, a dedicated teacher who made vital technical contributions in all areas of the society's interest. The 2021 recipient of the award is Yushan Yang of the University of Delaware for pioneering and leadership in the field of alkaline membrane fuel cells and for being an outstanding educator and mentor in the field of electrochemical science and engineering. The Alan J. Bard Award was established in 2013 to recognize distinguished contributions to electrochemical science. The award is named in honor of Alan J. Bard in recognition of his outstanding advancements in electrochemical science. The 2023 recipient of the Alan J. Bard Award is Joseph Hupp of Northwestern University for transformative contributions to our fundamental understanding of interfacial charge transfer reactions and for the training and mentoring of over 200 scientists. Please be sure to attend Professor Hupp's award talk, Toward Electrochemical Energy Conversion via Metal Organic Framework Materials, taking place on Tuesday at 2:10 p.m. in the Heinz Convention Center, room 203. Joseph? Next, we are honoring the 2023 winner of the Gordon E. Moore Award for Outstanding Achievement in Solid-State Science and Technology. The award was established in 1971 as the Solid-State Science and Technology Award. In 2005, the award was renamed in honor of Gordon E. Moore, who was the co-founder and chairman of the Intel and the father of Moore's Law. Sadly, Moore passed in March of this year at the age of 94. We hope this award serves as an enduring reminder of its namesake's incredible contributions for science and the society. The 2023 winner of the Gordon E. Moore Medal is Professor Fred Rooseboom, University of Twente, for fundamental contributions to more and more and more than more for rapid thermal processing, atomic layer deposition, atomic layer etching, and 3D heterogeneous integration. Dr. Rooseboom will present his award talk, Moore's Law Sustained by Non-Lithographic Technologies, on Tuesday at 9 a.m. at the Sheraton Boston Hotel, Fairfax A, on the 3rd floor. Congratulations. Lastly, we are pleased to recognize an inaugural recipient of the John B. Goodenough Award of the Electrochemical Society. This award was recently established to recognize distinguished contributions to the fundamental and technological aspects of electrochemical material science and engineering in the areas of batteries, solid oxide conductors, fuel cells, transition metal oxides, and/or magnetic materials. The award honors John B. Goodenough, the Nobel laureate in chemistry and world-known scientist, recognized for his myriad of contributions, including his role in developing the rechargeable lithium-ion battery. Moreover, Dr. Goodenough is a dear friend of ECS, and we were very fortunate to be at his centennial birthday celebration last year to launch this new award and present him with a bound copy of the special issue of JES named in his honor, and which is available in the ECS Digital Library on the IOP Science platform also. The first recipient of the John B. Goodenough Award is Arumugam Manthiram of the University of Texas at Austin for pioneering fundamental and technological contributions to electrochemical energy conversion and storage, involving the development of new materials, advanced characterization, structure, property, performance relationships, and prototype devices. We hope you had an opportunity to hear Dr. Manthiram's award talk, Oxide Revolution in Energy Storage, which took place this morning, but if you missed the replay, the replay will be available via the online meeting program. Ram? Congratulations again to all of today's award recipients and service recognition honorees. Thank you for your contributions to the science and the society. This concludes the ECS Awards and Recognition Ceremony, and it's time to move on to the ECS Plenary Lecture. Our distinguished speaker today is Dr. Linda Horton, Associate Director of Science and Basic Energy Sciences in the Department of Energy, Office of Science. With an annual budget of more than $2.5 billion, BES is the nation's leading supporter of fundamental research in material sciences, chemistry, geosciences, and aspects of biosciences. BES is also a major supporter of scientific user facilities, including the nation's premier X-ray light sources, neutron scattering facilities, and nanoscale science research centers. Previously, Dr. Horton was the director of the Material Sciences and Engineering Division in BES. Prior to BES, Dr. Horton was the director of the Center for Nanophase Material Sciences at Oak Ridge National Laboratory, one of 5 DOE national user facilities for nanoscale science research. Her personal research emphasized applications of electron microscopy to material science. She is a fellow of ASM International and has served on several national and international advisory committees. We're honored she is with us here today to give her talk, Sustainable Clean Energy, Foundational Research Challenges and Opportunities. So please join me in welcoming our featured speaker, Dr. Linda Horton.
Tracking down all the various, all right, I think we're good. Thank you all. I'm really glad to be here at the ECS meeting. I appreciate the invitation to the department to provide a plenary lecture on the importance of research in energy. This is an exciting venue. I know many of you it's nice to see old friends and to celebrate with you the great people that were honored tonight. So thank you very much. So I'm here to talk about energy, and I think that the President's remarks really were a great introduction to this presentation. When I think about energy, I often think of images. We need to make energy. We then use the energy that we have made, whether it be with industry, in our transportation, or our personal electronics, which is an ever-increasing use of electricity. But to solve the challenges of energy, we need to do enabling research. And that crosses the fields that many of y'all represent. I looked at this meeting and the presentations and the topics being covered, and they are pretty much covering the waterfront of the challenges that we're facing for energy in the country, but also in the world. If you look at U.S. energy consumption, the information showed earlier covered the world. This is the United States. You can see that the utilization of energy is topped out around 100 on this chart. But if you go look in more detail, this is the chart that's put out by Lawrence Livermore National Laboratory every year about how the U.S. makes energy and how we use energy. And this is the chart from 2011, which shows that we used about 97 quads. And if you looked at 2021, you would see it's about the same, but there are changes. Solar is up by about 10 times, wind is up by about 2 times, natural gas is up by 25%, primarily in industrial use and in the generation of electricity. So those are all good news, I think. If you look at the carbon dioxide emissions, again, this is 20 years ago for carbon dioxide emissions, and then this is today. And you can see there's been about a 15% reduction by the United States for carbon dioxide emissions, with about a 15% increase in population. Again, some good news, but we all know that's probably not sufficient. So one of DOE's missions is to ensure this country's security and prosperity by addressing the challenges for energy through transformational challenges, our science as well as technology solutions. So I'm here today from the Office of Science, but I know that many other people have represented DOE at this meeting that are from the technology offices, which are equally critical to science in arriving at the solutions that we need for energy in the country. So the Office of Science is a big place. We have a lot of users of our user facilities. We support researchers at over 300 institutions and 17 Department of Energy labs. Our goal is to deliver scientific discoveries and the tools that y'all need to do your research so that we can transform our understanding of energy at the very smallest scales through the integration across scales up to being able to develop the early stage prototypes out of the Office of Science that then feed into activities in the technology offices that result in commercial products. As mentioned, the Office of Science is one of the nation's largest supporters of basic research in physical sciences. If we look, there are, the DOE is responsible for 10 of the national labs. Not highlighted on this map are the NETL, NREL, the defense labs, Lawrence Livermore, Sandia, Los Alamos National Laboratories that are supported by other parts of Idaho as well. There's a number of national laboratories that are supported outside of the Office of Science. But again, the Office of Science supports over 29,000 researchers at over 300 institutions, which are the gold stars on this map. Now I have to step aside and say this is a new template for me and for the Office of Science, and the next time you see it, I bet those stars are a better color because they're practically impossible to see. But for now, it's good. The Office of Science supports 28 scientific user facilities. 12 of these are supported by basic energy sciences. There are over 37,000 users each year at the department's user facilities. Many of those are at the computers supported by advanced scientific computing research and the light, neutron, and nanoscience centers supported by basic energy sciences. This suite of characterization and synthesis and computational tools supported by BES and OSCAR are probably resources y'all are familiar with because they are used in energy research in academia, national laboratories, and industries. Really important part of what we support. One of the questions that often comes up in forums like this is how do we choose the research that we support? And that's through engagement of people like you in community-based workshops that result in reports. We call them the basic research needs reports because the focus of these community workshops is to determine the basic science research directions and opportunities that are priorities to solve some of the compelling problems facing us in energy and the environment, as well as other leading national priorities. We've done a lot of workshops on quantum, for example, and semiconductors. This chart shows a few of these recent reports. These are all available online. If you look at one in particular, here's the energy storage one, you can see that the priority research directions might well be the ones that you would have chosen yourself if you were looking at the challenges facing next generation energy storage for the nation and the world. We need to tune functionalities. We have to figure out how to link all the phenomena across time and space to go from small scales to bigger scales, from short-term batteries to longer-term batteries, to go from materials that are critical to materials that are earth abundant. We have to control the interface region. That's pretty critical in energy storage. We need to look at innovation. To look at the next generation, we can't just have incremental improvements in the materials and the chemistries, but we have to really revolutionize performance through figuring out how to more innovatively organize the materials and the architectures. And of course, we all want any kind of energy storage to self-heal, not have any detrimental evolution of the material's performance, and really have energy storage that lasts a long time and is very safe. So this slide is the highlights, but if you look in the actual report itself, you'll see that there's a lot of backup information. I just put one example in to show some of the questions that are behind the research priorities. And then, of course, there's the whole report. Associated with all of these basic research needs reports, and I'll go ahead and show the next one, are factual status documents. And they're intended to help you if you're a graduate student in the field, or if you're a professor and you have students coming in, or you're just wanting to understand what the challenges are. This factual status document is like a little tutorial that was written at the time that the workshops took place, that really provide the background for the community, for people outside of the community on what the status of the field was and the technologies and the challenges. One of our more recent reports is looking at carbon neutral hydrogen technologies, another topic that I know has been at this meeting, how we can generate hydrogen in a carbon neutral way. And they have priority research opportunities that were defined for this field, including revolutionizing electrolysis, which is a pretty well-established field, but a lot of opportunities for using science to really understand the phenomena and perhaps come up with better approaches. Understand what we can do to harness the full potential of hydrogen as an energy carrier, whether it be through better storage techniques or better utilization. Really understand and be able to understand the structure, evolution, and chemistry of interfaces. If there are two things that appear in many of these lists of priority research opportunities, interfaces is really common. Elucidation of structure, chemistry, and how it evolves is really common. And then the use of the computing tools, artificial intelligence, machine learning, to somehow better accelerate the rate of discovery and understanding of the phenomena. Let's see, there we go. New to the Department of Energy are energy earthshots, and you've probably heard about these previously. There have been now 7 of these announced. This is department-wide, so it's bringing the full weight of the technology offices, demonstrations, and science to try to really advance towards the goals of 2035 and 2050 in terms of energy utilization in the clean energy regime. So this slide has all of the goals, and you can see for hydrogen and for any of these, there's all goals about cost, there's goals about enhancing lifetime, enhancing capabilities, and doing all the things, again, that you would have expected. You would not believe how long it took to come up with these goals for these various energy earthshots, because it is very challenging, because they have to be rational from an industrial perspective and challenging from a research and technology perspective as well. The most recent one is on clean fuels and products, which include chemicals. So it focuses on decarbonizing the fuel and chemical industry to advance cost-effective technologies while lowering greenhouse gas emissions, again, by 2035. And you can see there's lots of critical research areas identified. Again, many of these are, you all have sections that address these areas, looking at some of the topics. So carbon efficient conversion processes, understanding sustainability, the whole gamut of what, again, you would expect if you were trying to develop a truly clean substitute fuel and better sustainable chemical production. Going back to the Sankey diagram, if you look at where these energy earthshots fall, you see they come over the full breadth of the, except for nuclear, the various energy technology areas in the Sankey diagram. And if you look at what reports that Basic Energy Sciences and our sister organizations have done, all of these reports are online as resources, again mapped onto the Sankey diagram. You see again that all of these regions are covered by reports that identify what the real critical energy research opportunities are for basic science. Now, we support research, and in Basic Energy Sciences, we support research across a full gambit of modalities. We have a very strong core research program that supports single investigators, supports small groups at academia and national labs. One of the modalities that was established in 2009, which was the year I joined the department as a federal employee, were Energy Frontier Research Centers. These are larger teams addressing harder problems and for longer terms. So most of our grants are about 3 years in length. The Energy Frontier Research Centers are 4 years in length. And the larger modalities, the energy innovation hubs, are 5 years in length, originally at $25 million per year. As we're going through the next iteration of these, they're from $8 million to $25 million, but again, still for 5-year terms. Also relevant to this community is, of course, the Fuels from Sunlight Innovation Hub, as well as the energy storage one. We also have quantum information centers. We have computational science centers in the smaller group, and a very brand new modality called Energy Earthshot Research Centers that are providing the science foundations for those energy earthshots that DOE is pursuing. And I'll have some more information on those. One of the things that we look at in basic science is how we can move from the science that we do to actual applications. And I have a few examples from history. This was research done at Stanford looking for non-precious metal, non-platinum group catalysts that they then developed into a lab scale device to see if they would work. And then it went to industry with SBIR funding to confirm its performance and hopefully result in a commercial product. This story is repeated over and over again. Not all companies that are formed out of these discovery to commercialization routes survive the long test of time, but they all make a difference towards that path towards commercializing discoveries out of science into something that will make a difference in energy technologies. Today we fund 51 Energy Frontier Research Centers, and I put this slide up to show the diversity of the technologies that are supported in this program. From the very first till now, we have a large number focused on energy storage. We also have always had ones focused on solar. We've had some focused on radiation effects and nuclear energy. We've had ones in hydrogen and carbon capture historically. But now as you look at this, we have some newer topics on advanced manufacturing and how we can use these larger teams to tackle some of the challenges for sustainable manufacturing, including polymers. Microelectronics is another new area. Separation science and subsurface science have become increasingly important over 10 years that this program has been in place. As another example, this one is from Berkeley, Lawrence Berkeley National Laboratory. This is focused on MOFs that have gone from the lab, looking at how we can improve MOFs for binding for carbon capture, again through an RPE project in this case, to do some analysis, develop some new high throughput technology so they can further improve the binding. And then a new company was formed and is located was initially located on the Lawrence Berkeley National Lab site that was manufactured these pellets to demonstrate that they would work commercially. One of the things that these 3-panel charts, or 3-column charts now say, is that success in moving from science to commercialization has a lot of partnerships. Partnerships among the researchers, partnerships with getting additional funding from the technology offices in DOE or elsewhere, and then of course actually getting a company up and operating, which often involves SBIR funding for the smaller companies, or in some cases a large corporation will take them on and further their development. The Batteries Hub, the Joint Center for Energy Storage Research, there was a whole session on this, so I don't need to tell y'all anything about J. Caesar, other than it's celebrating its 10th year, so it's in its final year right now. We are recompeting this program this year. There was a Department of Energy Secretary assessment that said that 10 years was a good time to graduate these really large modalities and recompete them, reinvigorate them, bring in new ideas. J. Caesar has been tremendously successful by almost any measure. They have a huge number of students that have gone on and are impacting, I think they have well over 300 people that have left J. Caesar and gone to industry. I think over 50% have gone to industry. Some have gone to national labs, some have gone to academia, some have gone to other countries because it's a very international business, energy storage. What J. Caesar did in the first 5 years was focus on prototypes and delivery of certain performance parameters. In the second 5 years, it returned to the roots of discovery, focusing on bottom-up battery design, bringing more data through the materials project so it's available to everyone for their research, additional software suites. It has been, as I said, extraordinarily successful. There have been 3 spin-offs associated with J. Caesar. This is highlighting Form Energy, which came out of MIT, which went from understanding the chemistries for anodes and cathodes and membranes in flow cells. They had their own little lab bench prototype that's shown on this slide. Very, very quickly with ARPA-E funding, the company Form Energy was formed. They demonstrated larger scale, longer duration energy storage. And today, Form Energy just announced they're building a full-scale manufacturing facility in West Virginia. They have several contracts to build a 1.5 megawatt pilot at Green River in Minnesota, and then a 10 megawatt battery system also with Excel Energy. So again, very successful. And another example, there was, again, SBIR, there's ARPA-E, there's lots of funding involved. I think that Form Energy in particular had a huge number of venture capital firms and other investments that contributed towards their success. So what's going on? For our 2023 solicitations, they're all out. The proposals are coming in. We're doing reviews. So I thought we might want to talk a little bit about the 24 requests. So for FY 2024, there is a request that is above the 23 budget for basic energy sciences, which balances research, user facility operation, and construction. On the research side, we expand the SC Energy Earthshots initiative that we supported this year. This has 2 parts, and there'll be another slide on that. We continue support for our team science, energy innovation hubs, the EFRCs, the QIS Center, and computational materials and chemical sciences. We are hoping to launch microelectronics science research centers. I think that this is probably one of the challenges that crosses every technology to have more efficient power electronics, better computers, better sensors. All that requires better electronics. And that's a very exciting area of research. The other area of investment that I'll speak a little bit more about is we've been supporting research for underrepresented communities and institutions to try to help ensure that everyone has a chance to contribute to the energy solutions for the country, not leave anyone out of the equation. But also, I think that most industries, whether they be in the United States or in the world, are suffering from workforce shortages. So getting people engaged with enthusiasm for this exciting area of research. I know I was first exposed to energy research when I was an undergraduate, and I learned about this thing called fusion energy. And then I went off and spent my graduate studies looking at developing of materials for fusion energy, and then that was like the beginning. And when I got to Oak Ridge National Laboratory, I learned about this thing called basic energy sciences, which took what I was doing with fusion and expanded using electron microscopy to look at many fields. And the enthusiasm and the energy behind energy research has just grown since that era. All right, back to the FY24 request. We have the SC Energy Earthshots Initiative. This involves not only basic energy sciences, it involves biological and environmental research and advanced scientific computing research, recognizing that the science foundations for the Energy Earthshot require all these disciplines. We have to have the best in computing, we have to use biological approaches whenever it makes sense, and then we need the materials and chemistry that come out of basic energy sciences. There are 2 programs, the Energy Earthshot Research Centers in 23 this fiscal year. Our competition for these centers focused on national laboratory-led teams, complemented by a funding opportunity called Science Foundations for Energy Earthshots, which is led by academic and private institutions for individual PIs. Again, you need everyone. You don't know where the best ideas are going to come from. It may be from a single PI grant, may come from a collaboration crossing disciplines, it may come from a team. It all depends. There's a lot of really excellent people out there, and we need as many opportunities for research as we can. So in this case, this is small group awards or, again, single PIs. So in 24, that will expand, in part because we have new energy earthshots that weren't included in the 23 call, and I expect, based on the website, that there might be one more announced this year. The website says there will be 8. Microelectronic Science Research Centers, which I've already mentioned. If you look at the CHIPS and Science Act, it authorizes up to 4 new DOE Office of Science research centers to look at the science part of microelectronics, complement what's going on. We've all heard, I think, about what the Department of Commerce is doing in this area. DOD also has a lot of investment in microelectronics, so this is to, again, build the science base for this field. There are reports, not surprisingly, on the website, and 3 of them are shown here. The other area that I mentioned that is becoming increasingly important is to ensure that everyone is involved. So we have activities that are to enhance diversity, equity, inclusion, and accessibility in the Office of Science programs. We have 2 new programs, recently new. One is called Renew. This is for minority-serving institutions, R2, minority-serving institutions, and emerging research institutions to compete for funding for internships at the national laboratories, or at R1 MSIs. Another new program is FAIR, again focused on the same sets of institutions, for research grants. Again, with the role of national laboratories and R1 minority serving institutions built into it. And lest we forget, about half of the states in the country do not have a large share of research funds for their universities. These are called the EPSCoR states. They're blue in the small map down there. And again, there's increased investment in the EPSCoR program across the Office of Science to help. This program has been around for a long while, but the recent enhancements are in going across not just energy research, but recognizing that fields like nuclear and high energy physics are also finding workforce very hard to evolve, and the program addresses those areas as well. And with that, I will stop and take questions, and I think there's a process for that. So thank you all very much.
All right, well, thank you very much, Dr. Horton. Dr. Horton has generously agreed to take questions from the audience, so we have a microphone set up here in the center aisle, so you can use that if you would like to do so. But to begin, Turgut, I know you have a few questions we were discussing over lunch with Dr. Horton. I think we want to continue that discussion here, so I'm going to turn it over to you guys.
Thank you.
Enjoy.
Dr. Horton, thank you for your inspiring and very informative talk. You've gone through a lot of programs, initiatives, all very instructive, also informative to our audience, because it shows where the opportunities are for new ideas and new programs in technology and in addressing these very important issues. Since we are a international society, I try to think of these of the energy climate space in a global perspective. There's lots going on in the U.S. and other technologically advanced countries, but then there is the other side of the world with vast regions and very populous areas where much of it is dependent upon fossil fuel energy. So this provides a technology gap between the fortunate ones and the unfortunate ones in terms of technology accessibility. So what can U.S. and the Western societies or countries can do to close up that gap?
Well, that's a very interesting question. I think that the United States has been really great in reaching out to other countries through memorandum of agreement and to collaborate in research areas, so that at least with the countries that are actively working in the field, we're at least working together. Mm-hmm. So I think that's important as an important first step, right, is that we are at least accelerating progress through international collaboration. Likewise, our user facilities are open to everyone. Mm-hmm. So the U.S. user facilities are used by a lot of international participants that come here and do research at the U.S.'s user facilities. I know that in some of the grassroots efforts out of, for example, I remember one of our early energy frontier research centers was focused on solar energy, and they then developed products that were appropriate for third world countries. So I think that a lot of the energies of the research community are in the right directions. I agree we can do more. Thank you. But, yes, I think so.
The floor is open for questions. I can keep the conversation going. Just a little longer maybe, but I encourage everybody to walk up to the microphone and ask their questions. Please do so. I don't know why here, okay. I thought my microphone was off. Let me touch upon, you mentioned about hydrogen energy and hydrogen initiatives. But among those, I sense that the emphasis is on electrolysis, electrolytic hydrogen generation. But I didn't see anything on, say, photoelectrochemical water splitting, where you don't have to worry about where the electricity comes from, and you use photons for that matter. Is there any? What are your views on photoelectrochemical water splitting?
If you look at solar fuels, that's one of the steps, right?
All right.
If you want to go from solar energy and use water and carbon dioxide to make a new fuel, solar fuel, a liquid fuel, that's part of that. So we explicitly excluded that from the hydrogen one, because we have a whole report on liquid solar fuels and the research priorities. So yes, it's very important.
So it's not just CO2 to fuels, it is water to hydrogen as well. I see.
Yes,
okay. Well, that's
absolutely.
great.
One of the things, so as a material scientist, so I can speak to this group. So I'm a material scientist. I did not have any degrees in chemistry. But one of the things that I have learned since being at Basic Energy Sciences is that catalysts are ubiquitous in energy systems.
Yes.
They are used everywhere.
Yes.
And I really applaud all the efforts to control. So in material sciences, we do worry about designing the substrates upon which the catalysts are going to sit. Yep. So we can maximize the performance. So that's an example of a system that crosses that discipline line between material sciences and catalysis, which is very much in chemistry. But there is a lot of research in non-platinum group catalysts, in improving the interfaces between the catalysts and the substrates so things work as well as they possibly can.
Yes.
And those research areas, again, that's probably another one I should have mentioned. If many of the basic research needs reports have something in them about catalysis, because it's so important.
Right, it is. It
Yeah.
is. I see Shirley moving up the microphone. Thank you, Shirley.
Hi, Linda. This is Shirley Mun, past chair of Battery Division. I feel obliged to ask you a question since Battery Division is the largest division of the Electrochemical Society. So first of all, thank you for this very informative plenary talk. We learned a lot about what BES is planning. I'm particularly impressed by your 3-column slides where you showcase how fundamental science had a true impact that all the way to society. I was just wondering, given how much the industry has grown to a nearly $1 trillion industry, could you give maybe the society at large some kind of suggestions or insights that how we can make this connection between basic science to the societal impact more accelerated? I would say that in the United States, when manufacturing is coming back here, and it sounds like there will be a lot of incentives, and I just wonder if you could speak about, how could the students and the professors and the scientists and technologists think to this, to accelerate from fundamental breakthrough to society impact?
Oh, that's a great question, Shirley. Obviously, some of that's in the energy of the performers, of course. We have reports like there's a report on BES at 40 years after basic energy sciences that really talks about many of the broader impacts of our research, including energy storage, but many other things. because it's always very surprising to see where basic science makes a difference, or even high energy or nuclear physics. Every discipline is sort of part of a continuum that helps to lift everything up together. So we all have to work together. There's no one discipline that's more important than another when it comes to basic science, I don't believe. So your question is, what can we do? What more can we do?
Right.
Gosh, that is a difficult one.
I was thinking perhaps many of us can send you the slides in the similar format.
Yes, well, we do try to collect this information from our performers. So if you go onto our website, we highlight the science, and there is a standard format that we get from folks that supports that. And we do look for the stories. We have probably, we have tens of stories in basic energy sciences that document I picked ones that were most relevant to this group. But yes, we do, that is something that you as a research performer can do, is make sure we know. Mm-hmm. And what we're trying to do is reach out to our colleagues in the technology offices. One of the things that happened in parallel with the energy earthshots was the formation of even stronger cross-department teams to manage the program. So the basic science discoveries get communicated to the technology offices, and as the technology offices' challenges evolve, we hear about those so we can communicate them to the performers in the basic research community, and in forums like this, or in our PI meetings, or in other communications. So I will put it back at you. So you tell me what we need to do to better communicate your developments. And since I've been at DOE, one of the things they've done is to reach out. When a paper appears in one of the journals, they reach out to your universities. National labs, they're sort of a captive group. They know they have to issue press releases. But to find out if you want to do a press release about your paper, and then we publicize it, which is part of reaching out to the community to tell them how important the science is, how important the discoveries are.
Yeah, absolutely. And I want to say I grew up with the EFRC program, literally, and I think the other really big thing is the workforce that BES has put out to our community. That I met many students in the industry that are EFRC students, so
yes,
congrats on that.
We've had the first EFRC postdoc is now a PI.
Yes.
So
great.
it's really gratifying to see the young people coming up through these team research modalities, because that is really important. It's really important that the single PIs, very important as well, again, but people learning to work together across disciplines really can help accelerate science. So thank you.
Thank you, Linda.
Thank you.
So thanks, Linda, for the wonderful talk. Amy Marshlock, Stony Brook University, Center for Mesoscale Transport Properties, and Brookhaven Lab. My question is, from your perspective, running a nanoscale research center at Oak Ridge, and then now also, in your current role, do you think there's a role that the nanoscale research centers could play in light of the new emphasis on workforce and workforce development that we're seeing nationally, and especially being articulated through DOE? It struck me through the work we do in our own group at the Center for Functional Nanomaterials, techniques like electron microscopy, modeling, are tools that are becoming more and more important for different types of industry. And there's a really interesting role that the centers might play from that perspective. So I was just curious about your thoughts there.
Yes, thank you. That's a great question. The nanoscience centers, but more broadly, the BES X-ray and neutron facilities, plus the nanoscience centers, most of the people that use those facilities are young people. So the faculty come, yes, but the majority of the numbers that you read about the users are mostly young people. So there's a huge training that goes on at those facilities. The nanoscience centers are perhaps relevant because they have synthesis. You know, the light and neutron facilities do characterization. Now they do have some lithography kind of capabilities with those focus beams, but in general, the synthesis side and the theory side come to play at the nanoscience centers. So I agree, it's a really great resource. We're actually doing an assessment on future directions for our nanoscience centers, to make sure we capture those kinds of things. So I do appreciate that input because it is important. These new modalities we have, like the internship program, or we do a graduate student fellowship program, those all involve funding for people to go to the national laboratories to do research. And the user facilities are indeed an important part of that. So thanks, Amy.
Thank you for your great talk, Linda. The question that I have, coming from Europe and enjoying this ECS very, very much, I would have a question which is more maybe financial, political, rather than scientific, technological. I heard this earlier today, Christian Uzi talk about reaching out to Korea, Japan, what have you, to intensify those activities on a society level. But would it be possible, maybe not this fiscal year, but next fiscal year or so, to initiate also from the side of DOE, so from the department and the national government, sort of transnational, or call it pan-Atlantic or pan-Pacific programs, financially backed up, technologically making a synergy to the other continents and accelerate that way, the need for global action?
So the Department of Energy has memorandum of agreement with many countries, including Japan and Korea, and many countries in Europe and India and so on. The list is rather long. So there is efforts by the department to ensure that we have agreements in place that promote dialogue to accelerate the research that we are that various countries are doing. So there's lots of communication. There's also a lot of discussion about what we parallel funding, shall we say, where NSF does this already. They have programs where the proposal is reviewed in the United States by the NSF and by another country, and the other country funds their researchers. They fund the U.S. researchers, and they work together on a common project. For DOE, we historically have done much of that through collaborations with funded awards, especially like the Energy Frontier Research Centers. We just had a workshop that I know Amy was at and Shirley was at, the Japan workshop, where we had people that were funded to do research talking with the Japanese people who were also funded to do research to encourage that they work together more closely. So there's a very low bar on that. You may be familiar with like a lot of the EU programs, like the Horizon program. A lot of these programs you get into trouble with if you have a lot of intellectual property things. So it's really not to our advantage for US researchers to take money from the EU and then give them all of the intellectual property, which historically has been a bit of a challenge in getting the right balance between those kinds of things.
I'm aware of that, especially the EU sort of initiatives, crossovers with over the Atlantic and so. But I would really invite, you and everyone here to sort of do whatever they can to also on a political level to really promote it and, for example, also show a slide on that sort of internationalization of this, well, grand challenge in energy. Thank you.
Thank you.
Do I see anybody else? No, I guess not.
Perfect time.
Yeah, perfect timing.
Yeah.
Before we wrap up, we do have a minute or two left, so I want to ask, I know Linda, that you've been into other ECS meetings in the past, and you've been very active in other societies throughout your career. Could you maybe, as a final question before we part, share a few words about the role that technical societies like ECS and others that you've been involved in have meant to your career and the role that they play in ameliorating challenges that we're facing right now?
Well, thank you. That's a great question. So my very first professional society role was before I had any children. I was the treasurer secretary of the Electron Microscopy Society of America. And that was a great time in my career to get involved with professional society because of the networking, learning what other people are doing. At that point, electron microscopy was really accelerating in the impact that we were able to have with that tool. And it was just fantastic. As my career moved forward, I also was involved with ASM, which is more of a metals-focused group, materials-focused groups, and then Materials Research Society. And the symposium at these meetings were an opportunity to invigorate my research. I was just thinking about that today. Just you sit and you listen and you learn and your mind goes wild as to where your research might go based on the interactions and listening to other people. And the international component, we were just talking about the international component. The international component of these meetings just cannot be replaced, in my opinion, because that's the scientist to scientist interactions are so important to your career, to making progress, to accelerating your ideas, to not duplicating what someone else is doing already, and getting ideas as to where your research might go. So I would say, and this meeting has reminded me of the importance of the person-to-person in giving a presentation. You know, the Hollywood squares and the Zoom boxes just isn't the same. You don't get that. You don't get the eye contact. You don't get the reinforcement of the energy of the room for the enthusiasm for the field. So, yes, very important. Thank you.
I'm glad you shared that insight with us. I think that's a great spot to leave it. And thank you very much for your time today, Dr. Horton. It's been great. It has been an honor for us to have you here today, and we would like to present you with a scroll in appreciation of this wonderful presentation and the conversation and dialogue that you've led with us today. Turgut has it here for you. It's a small token of our esteem. Thank you so much, Dr. Horton. Well, this has been wonderful. Thank you, everyone, to you participating in today's ECS Awards ceremony and plenary lecture. Before we wrap up, I should mention that the 244th ECS meeting will be held in Gothenburg, Sweden, our international destination, from October 8th to the 12th in 2023. After that, we'll be moving to San Francisco in the spring of 2024. Abstract submission is actually coming up in August, so I know that meeting sounds like it's a long time away, but abstract submission will be open this summer in August, and then following that, we will be looking forward to seeing you at Prime 2024 in Hawaii, and believe it or not, abstract submission will open up for that in November, so not far off there. Most importantly, the exhibit floor is now open. It is located in the Heinz Convention Center, Hall A. So please join us as we open the technical exhibition and host tonight's first general poster session. So that will be some exciting stuff. Please make it a point to visit our exhibitors while browsing the posters. We know that they are very eager to see you. So this concludes the ECS Awards recognition ceremony, and it is my great pleasure to thank again Dr. Linda Horton. Thank you, everyone. Welcome again to Boston, and have a fantastic meeting this week. Enjoy. Thank you.